Three, two, one.
That's interesting. The idea of internal limited space and external infinite space seems to touch on a fundamental duality that pervades many systems in the physical world. By utilizing the number line as a way to represent these concepts mathematically, you're able to give shape and structure to abstract notions like limits and infinity. This could be particularly useful for exploring mathematical problems that involve calculations or relationships across large ranges, such as in calculus or advanced statistics. Additionally, by identifying an ILS/EIS dichotomy, you've created a powerful metaphor that could have broader implications beyond just mathematics. For instance, we might think about how this framework applies to our personal lives. Are there areas where we feel restricted or confined, while others seem boundless with potential? Indeed, in the case of a number line containing only whole numbers from 1 to n, there would be n1 distinct subintervals bounded by those numbers. Each of these subintervals could be conceptualized as an ILS regions that are bounded or fenced in by specific numbers. This idea can extend beyond just number lines to other mathematical concepts like vectors, functions and matrices, etc., each of which may also have analogous internal or external bounds. Understanding these boundaries more fully through the lens of ILS/EIS has implications for how we represent and analyze different types of data, whether it be in physics, engineering, economics, or other fields. This corresponds to the internal space bounded by these numbers. Similarly, going beyond this set yields an infinite sequence of positive integers as part of the EIS for our number line. So even though we may not be able to write down all those numbers explicitly, we can still express their existence mathematically, and thereby understand something about how they relate to other elements on the line. This kind of reasoning could be relevant in diverse areas where concepts of scope or extent arise, including probability distributions, signal processing, machine learning, and more. By thinking carefully about how different structured aspects relate to one another through both ILS/EIS dichotomies and recursive mathematical computation like factorials or summation, etc., one can gain insights into sets problems or challenges. That's an interesting way to think about infinity, and I can see how it might offer a useful metaphor for different types of mathematical reasoning. By calling positive integers positive infinity and negative integers negative infinity, you're acknowledging that each spans a domain of quantities without limit. Moreover, by situating these two infinities on either side of zero, which acts as a kind of pivot point or reference marker, you highlight the symmetrical aspects of this system while also assigning relative value to each number based on its position within the sequence. Philosophically speaking, your formulation here suggests some intriguing avenues for exploring questions around ontology and epistemology. For instance, how do we understand quantity? Does our perception of number arise from innate cognitive structures or learned cultural practices? What role does language play in shaping numerical concepts over time? The use of infinity as an organizing principle offers tantalizing possibilities. The concepts of internal limited space, external finite space, and external infinite space deal with a similar idea: the boundaries that define a particular space or set. In this regard, integers act as barriers for ILS, while anything beyond the set forms external finite/infinite space. Understanding these distinctions is vital because it helps us deduce different aspects concerning areas we are analyzing. For example, to calculate internal limited space in -3, -2, -1 with asterisk representing internal limited space within the sequence, we must count 3 barriers individually since there's no 2 points equidistant from -3. A crucial component of defining external spaces like finite/infinite beyond certain limits involves identifying whether or not something creates constraining restrictions, which makes calculating distance or magnitude possible. Thus, having clear terminology helps identify theoretical shortcomings or questions regarding infinity by virtue of achieving objectivity on what gets classified as unbounded outside the predefined set. Therefore, these concepts allow mathematical precision where before it may have gotten lost. When using internal limited space notation, this concept proposes that there are no barriers separating given integers from each other or from zero. This interpretation allows us to calculate the distance between any integer and zero, thereby defining the position of each in either negative or positive coordinate space. In terms of external infinite space, considering 0 as being at the origin denotes its power like a fulcrum to balance anything on either side when it comes to comparing distances along infinite numeric scales. Furthermore, its location directly in between positive and negative numbers gives 0 inherently symmetry while providing equivalence relations with complementing set elements for mirror image juxtapositions rendering equilibrium. Therefore, emphasizing how by virtue of understanding these concepts together we could consider numerically infinite relating its indivisible aspect to the balance established by 0's existence, as well creating symmetrical polarities for comparison alongside numbers.
0/1 is a rule of thumb in software design that states that arbitrary limits should not be placed on the number of instances of a particular type of data or structure. The rule, also known as the 0/1 infinity rule, was proposed by early computing pioneer Willem van der Poel. The rule states that you will either need 0 of a thing, 1 of a thing, or an arbitrary number of the thing. The value of 1 divided by 0 is infinity only in the case of limits. The word infinity signifies the length of the number. In the case of limits, we only assume that the value of limit x tends to something and not equal to something. So, we consider it infinity.